Okay. Perfect. All right. Thanks, Andrew. Thanks, Julia. Okay, so let's keep going. Let's see. Looks like quite a few have started working on the assignment. There were a couple of syntax mistakes that some students were pointing out. And in particular, I believe it was in the update here in the updating data. I was missing an extra curly bracket at the end. So I believe right here and right there, I was missing an extra curly bracket. So I've fixed it. So that should be okay. Also, I was missing double quotes around this economics. And so I've added that. So that should be okay. Also, some students were saying that they weren't able to dump the database, and I believe it's because they haven't installed the tools. You do need to navigate to the tools. Right? If you click on tools here on the MongoDB download, and you go here in the MongoDB database tools right here, and you download it. Right? When you download that, you can unzip that in the downloads, which I've unzipped it. And what I did is that I copied the contents into my program files. And I believe what I did is I copied all the tools. I copied them under the bin directory. Right. So for instance, there's Mongo Dump, .exe, export, import, restore. All those are in the database tool. So if you don't download that and you unzip that, it's taking just taking a second there to download. Come on. Okay. So if you look in there in the there's a bin directory in there, and the tools are all here. See that? So what I did is I just unzipped this whole thing, I extracted it, and then I copied all these .exe files into the bin directory of my Mongo installation. And since the bin directory is already in my path, then you should be able to see all the tools, right? So on PC, if you go to the environment variables, you can just edit those environment variables and just add the bin directory here in the path, and then you either restart the machine or you start a brand new terminal. Okay. On Mac is a little bit more involved for the exporting the path. You do need to edit your bash profile. So it's a little more, it's Unix based. So yeah, you need to edit that. And I tested this yesterday. I had some folks come in during office hours, and we tried it out. I helped with, and we were able to configure this for them successfully. So I know that this not only works on my machine, but it works in other folks' machines. So that should be okay. Other than that, as I see other folks working, let's see. We were able to try out the dump on several folks' machines. This DB shell, I noticed that some folks, right? I was able to corroborate that everybody seems to have this file in their home directory. Right, so on Windows, to go to your home directory, if you go into, well, you might already have a home directory here in your left-hand side. Notice that there it is. See that DB shell is right there. Okay. Or if you don't have the home directory here on your left-hand side, you can go to your C drive, and then go into users, and then that's my home directory right there. Okay, and in there you should find the DB shell. Right, if you open it up with a notepad, right, you will find that it's basically a log of every single command that you have written in on Mongo, and this is perfect for the TAs to verify that you did all those commands and you type them all in the Mongo client, right? So this is perfect for them. Okay, yeah. In isn't it the default shell now on macOS? Probably. Yeah, right. The new macOS might have a different shell, and so yeah, the setup for the path might be slightly different. Yeah, yeah. Do whatever you need to do for your particular operating system. Okay, so yeah, so definitely please include that DB shell as well as a dump of your database. You can zip that up and provide that for when you submit it in your in Canvas. Okay, so let's go over just to see if there's anything that we need to review. Let's see, there's a question on the chat. Where can we find bash profile? So on a Mac, if you go to your home, into your home directory in your PowerShell, I don't have a Mac here, but if you do a CD enter, that will put you in your home directory. And if you do an ls, so ls lists the content of your file system in the current directory. Now, there should be a bash profile right here in your home directory. If there isn't, you can create one. Is there touch? No, I don't have touch. If there isn't, you can create one. And indeed, I did for a student that see right here, I have a bash. See that? There will be one called bash profile, a bash profile, and in there you can open that file up and then type the text that I'm suggesting right here. This. So what this is going to do is going to add your Mongo bin directory in the path, so you can run all the commands. Now this assumes that your installation is inside of MongoDB, and I do tell you to rename it. Right, yours might be something like MongoDB macOS x86 something or other. So yours might have a slightly different name. I'm asking you to rename it to something easier to remember, just MongoDB, just rename that. And so this assumes, right, that you have indeed renamed it. Okay, whatever that is. Okay. Let's see, a question on the chat. For the macOS, shall we use termination? Shall we use termination? The terminal, you mean, to get that? The terminal, yes. What if if we don't have it's bash profile, not dash. Okay, careful, right? It's bash profile. If you don't have one, you can create one. You can create a brand new one using your text editor. Yeah, you can just create a using Pico on a Mac. Pico is a very small, tiny text editor, or you can use text edit. I think it is on Mac OS, or any text editor. You can create the file. On a Mac, you can create a brand new file by saying touch, and then .bash profile. That will create an empty file. Right? I don't have touch because mine is not a it's not a Unix machine, but Mac will have a command called touch. This will create the file, and then you can edit it with any file editor. Okay. If everything fails and you cannot add it to your bin, to your path, that's fine. You can still use the full exactly where it is, right? Mine is in program files, right? If you know the exact location of and I think it's MongoDB, then server, then 44 bin. You can if you know the entire path of where the executable is, like for instance MongoD, for instance, or MongoD like that. You can do that too, right? If you absolutely don't know how to set up a path on a Mac, that's totally fine. You can use the entire path of the executable and just run it that way. You know, that would work as well. Obviously, it's more convenient if you have it part of the path, so you can run it from anywhere in the command line. That's definitely much more convenient. But again, you know, if you're not a command line wizard and you don't feel comfortable working with on the terminal, then this will work just fine as well. Okay. All right. So we had started playing around with the assignments, and I believe and let's see, created here. Let's go to documents and NEU, and then DB design. We had taken a look at the assignment on assignment number 3. We go to MongoDB. Right, we played around with it yesterday here, and we created the directory for the database, right, to dump the database in there, and we started the server saying MongoD, right, and then we can specify the path of where the database was stored. So you can say data, and this works just fine. Notice that it boots up and the server is up and running. Again, if you absolutely were not able to add the bin directory to your path and that's still not working, again, the worst case scenario, what you could do is that you can start from the root, either / on Windows or / on a Mac, right? You can go to if you know the exact location, right? You can navigate all the way to the executable. So you say MongoDB server 44 bin, and then this would be MongoD, right? And then DB path equal data. Oops, wait, MongoD. Oh yeah, exe. Sorry, MongoD exe, and then DB path equal data. Yeah, that works as well. Okay, so again, if you absolutely were not able to add the bin directory to your path, then you can use just a full path of where the executable is. Right, that should work as well. Yeah, so right, this is exactly where we left off yesterday, Tuesday. We started the server, and then we in a separate PowerShell or in a separate terminal, right? We started the client, right? So we did MongoD, just Mongo, and this connected to the database, and we were playing with the database. I think we called it whiteboard. So we say use whiteboard. We took a look at a couple collections. So we show collections. We play around with a users. Oops. Right, we created sections, we created users. We saw that we were able to retrieve and look at the data in there. We can say, you know, we can say db dot users, and then find that retrieve all the users, and that we could pre-print them just so that easier to read, right? Same thing with sections. Right, we created a couple of sections, and we were just playing around with that. So let's keep going. So let's see, install, testing, right? We did that. Start the Mongo client, show DBs, right? We did this already, and we created a database. We showed how to do that yesterday. We called it whiteboard. Here in the assignment, we're asking you to call it DB design. And we saw how to do collections. We were able to insert a couple of users. We showed you how to do that yesterday. Show DBs, we're able to insert. We played around with that yesterday. We saw that. Here we inserted a couple blogs. we saw how to do find. We played around with that yesterday. Yeah. And then we ask you to do a couple things, right? Just once we show you how to insert, then we ask you to do it. We also queried a couple of data, and then we're asking you to retrieve data either by object ID, by a particular topic, or by a given query, right? A particular predicate. And we all demonstrated that yesterday using the sections where we can do the seats, right? Seats that are greater than or less than. So this certainly should help you do your own. We then ask you to do it on your own, right? Once we show you how to do it in blogs, then we tell you, okay, well, now you try it, right? Retrieve documents that meet these criteria, right? We then play around with update, which again yesterday we demonstrated how to do that. Making sure that you got to be careful whether you use or don't use the $ set, so that if you don't use set, right, it replaces the object, whereas $set allows you to modify an individual property. Okay, so we demo this for you for blogs, right? We update the revenue of a particular object, and then we do it for economics. Okay, and then we ask you to do it on your own, right? So play around with it on your own. Deleting, yeah, yesterday also we demonstrated being able to remove a particular document here, and then we ask you to do it, right? So remove a document from posts. So we do it from logs, and you do it from posts. Then at the end, right, you're going to have the log of all your commands stored in DB shell, and as well we're going to ask you to dump your database using the Mongo Dump, right? So for instance, let me cancel here. Oh, actually no, let me leave that alone. If we go into documents, AU, DB design, and then 3, and then Mongo database, we have a dump. Let me see what's in the dump. Right, the whiteboard, right? So we can look at the whiteboard. Notice that when you dump, right, you tell it what database you want to dump. In our case, we dumped the whiteboard database. And notice that it has all the content that's in there, right? The users is there, the sections is there. Okay, so you're gonna zip up the this dump directory. You're gonna zip that up into a zip file, and that's what you're gonna submit to us when in Canvas, right? So together the DB shell and this dump directory is zipped up. So with that, the TAs can load up your database, right, and keep playing with it and see what the content is. Okay. All right. I think that's it. Let's head back to the presentation. So right now we talked about being able to manipulate or interact with individual collections and records in there. Let's talk about something a little bit more advanced. Being able to do many-to-many, for instance, right, where you have records that relate to many other records. Like, for instance, if you have students enrolled in many sections, right? One student can be enrolled in many sections, and one section can have many students enrolled in it, right? Or actors in movies, where one actor can be acting in many movies, but then one movie can have many actors. So that's many-to-many. And we saw that in UML, that can be captured in two different ways, right? We can either use this line between the two classes that are related, and then a dash line with the enrollment table, or you can draw it the other way, where you have the enrollment table just have two one-to-manys, right? Between student and enrollment, that would be a one-to-many between student and enrollment, or one-to-many between sections and enrollment. That's another way, right? That you can draw it. The more modern way is to use this notation, right? Where you have a line and then dash. That is if the enrollment has other fields, right? It has maybe, the year, or the grade that you got, or who taught it. So if you have more than just the links, if you only have the links, right, the foreign keys, then typically you capture it with two one-to-manys, two one-to-manys. But here, enrollment is going to have more than just those two fields. So that's why we're capturing this one. We call it an association class. We call it an association class, right? Now in the actual implementation in the relational world, the only way to implement it, right, is to have an extra table, and that extra table has foreign keys to the two other tables, right? So student and section has primary keys. Each one has primary keys, but then the enrollment table is foreign keys to student and a foreign key to section. That is the only way to implement many-to-many in a relational database, right? But but here in JavaScript, there are other alternatives, right? Because now each record, right, can have an array of values, right? Right, in a relational database, a field can only have one value, right? So if a foreign key can point to only one single primary key, right? And that's it. But what if that field, instead of having the single value of one primary key, what if we could have an array of foreign keys, right? That you can point to a whole bunch of things, right? And that's exactly what we can do here in Mongo. You cannot do that in MySQL, right? But you can do it here in Mongo, right? So here is the classical implementation, right? The classical implementation is to have one record have a foreign key that points to the primary key of another record, right? That's a classical way of implementing, right? So, for instance, if enrollment is the mapping that maps students and sections, right? The enrollment has one foreign key that points to the section and one foreign key that points to the other, to the student ID, right? So each foreign key points to the primary key of the other, and that's how you make the relationship many-to-many. But, right, and this is how you implement it in MySQL in a relational database. But here in a non-relational database, you have more options, right? In options that entirely remove the need for even having this additional enrollment table, right? Instead, what we could do, not that you would do this, but you have the option. Here's the option. Let me explain. Instead of having this intermediate enrollments, right, where it points to what students are enrolled in what sections, right, saying that these two students, for instance, are enrolled in the same section 1, right? That's the classical many-to-many, right? Or vice versa, right? The same student can be enrolled in two different sections. That is also true, right? So only way to implement it in a relational database. But in a non-relational database, you could absolutely do it another way. You could have a field where that can be an array, right? That instead of having one single value, right, that points to one single primary key, it could be an array of primary keys, right? That it can point to multiple primary keys, right? Where this could be sections, plural, and then have the primary keys of each one of the sections where that student is enrolled. This entirely removes the need for an enrollment object of an enrollment table, okay? Because I can, the student can have its own references to all the sections that I'm enrolled in, and same way in the sections, or the sections can have a students array that points to all the students that are enrolled in that section. See that? Now there would be no need for an enrollment table, okay? And that in that implementation, you would have, it would look something like this, right? Where you have the student have a section field where the student 1, right, would have an array of saying, oh, I'm enrolled in, there it is, right? And student 2 also is enrolled in the same section and pointing to that same student, okay? Where student 3 is enrolled in 2 sections. So it would have an array of the 2 sections that they are enrolled in. Again, these would be references, meaning the ID of the section that I'm enrolled in, okay? If I actually need the section object, I would need to make it a separate query with that ID to actually fetch that section. Okay, somewhat what a join might do. Okay, now if you look at this is viewed from the point of view of the student. Now viewed from the point of view of the section, right? You would have that the section would have references to the students that are enrolled in that section, right? So for instance, section 1 knows that both student 1 and student 2 are enrolled, and in here, section 3 and 4, right, would point to the same student because that same student is enrolled in these two sections. You see that? Now this begs the question of wait a minute, this looks like there's some redundancy here, right? Because if you ask from the student's point of view, the student point of view says that, hey, I'm enrolled in those sections. It would be an inconsistency if somehow we ask the sections, hey, who's enrolled in these sections, and somehow it would not, the same information would not match with the students, right? I mean, it would be inconsistent if student 1 says that they are enrolled in section 1, but then not have this, right? That would be inconsistent. That the student says that they're enrolled in the section, but the section doesn't know that student 1 is enrolled in that section. That would make no sense. Okay, so in that sense, there is the risk of inconsistency. That depending if you ask it from the student's point of view, right, that might not for some reason be the same as if you ask it from the section's point of view. Okay, so this implementation, even though you can do it, even though it's perfectly fine. We try to avoid this, especially if you are writing the code that does this, right? Instead, oftentimes when we want to implement this, we would use some kind of an ORM, an object relational mapping tool that would fix this, that would automate this, right? And make sure that the data is consistent, right? And avoids the possibility of inconsistency. Okay. The implementation will look something like this, right? Where you have, if you're implementing it the classical way, right? Then the enrollments, you would insert an enrollment document that references both the section and the student. Okay, that's the classical way. You're pointing to two foreign keys. Okay, or if you implemented from this more modern way where you have arrays, you could tell the student, right? For a particular student, I want to add a new sections array that contains, notice the array, see that, the square brackets, and I'm enrolled in that one section. That's the ID of that section. Okay, that makes sense. And vice versa, right? Vice versa, the student would have a, oh, I'm sorry. Yeah. Here, notice that we are. Yeah, no. Chrome stopped working for a second. Yeah. So notice the set is saying the sections is going to have an array. Let's try that, right? So let's see. Let's bring up the Mongo, and show DBs, and we can say use whiteboard, and we can show the users, not users. I'm sorry, db.users.find.pretty. So these are my students. So that's just Wonderland, right there, and let's enroll her in a section. So if we say db.sections.find. So for instance, let's enroll her in this section right here, right? So we might say, I'm going to update Alice, right? Because she's a student, and I'm going to filter by this ID. So I'm going to copy that. I'm going to say db.update, and I'm going to update the student who has the ID. Oh, it's not letting me paste. There we go. Yeah, that one. Let me close the curly bracket, and I'm going to set $set a new field called sections that has the value as an array, and this is going to be the section. Let's see, section. I'm going to enroll her in section 1 right here. So I'm going to copy this right like that. Copy. There we go. Okay, I'm going to close the sections, close the set, and close the update. Oh, this is the student, right? Users update. There we go. All right, so if we print out the users again, notice that now Alice has a new field called sections, and notice that it's an array. See that? It's an array. So I'm able to say Alice, right, is enrolled in that section. Now, it would be inconsistent that if you ask the sections that the section would not know that Alice is enrolled in that section, right? So right now the database is in an inconsistent state. If, right, we're assuming that this is many to many and that they both should know about each other. Okay, so this should be accompanied by saying db.sections update the section, oops, right, the section, this one, ID right here, copy. Okay, and we're going to set is enrolled in that section. So let's copy that. Okay, and paste it here. There we go. Okay, so if we ask the sections, notice that now the section knows about the students and the students know about the sections. See that, right? So again, the problem here is that you can easily run into inconsistency where you update one, but you forget to update the other, right? So typically we avoid updates where you have to update two things, right? Usually it's a bad practice that whenever you do an insert or an update, that you are forced to do two updates at the same time, right? We avoid having to do that. Okay, so that's why we often just come back to this classical implementation where we have a single table that we update that one table and establishes the relationship between the two, right? Again, but I did want to point out that the option is there if it makes sense to you. Let's look at something a little bit less controversial. Instead of a many to many, let's do a one to many. So one to many is not going to be is not going to have this problem, right? Let's consider these relationships: faculty authors many courses, or faculty teaches many sections, right? Again, the classical implementation is that you have a foreign key, right? The section has a foreign key that points to the primary key of the parent, okay? Or courses point to who the author is and points to the faculty, right? So they both have foreign key that reference the parent class, okay? This is a classical implementation. That's how you would implement it also in MySQL. But, right, because Mongo is object-oriented, right, and you can have arrays and objects nested, hierarchically, you can reverse the implementation, and instead of the children, the sections and the authors pointing to the parent, right, instead of sections pointing to the faculty and courses pointing to the faculty, right, we can reverse that implementation and have the faculty have arrays of the courses that they teach and arrays of the sections. I'm sorry, faculty, the array of sections that they teach and then the courses that they author. So now an alternative implementation is, if we reverse the implementation, is that faculties would have sections that they're teaching or courses that they have offered, right? And then they have arrays of references to their children, right? Which conceptually might make more sense, Okay, instead of the children referencing the parent, it is the parent who references the children. And this is absolutely perfect. You know, this would be an even better implementation than having it this implementation, right? We would probably abandon the old implementation of using foreign keys of the children pointing to the parent, and would prefer this array implementation. But there's a third option. There is a third option. Okay, the third option is to instead of storing the values of the primary keys, right, the values, instead of doing that, we could embed the entire object in here, right? We can embed the entire section object in there, right? So for instance, you know, the sections taught, you would have the actual, you know, JSON object with all the curly brackets and all the properties and all the arrays and anything as complex as a section might be, right? Embedded entirely inside of the array. Okay, that is yet another option. Okay, let's look at the this first one right here, this one right there, this option, right? So in that option, this is the classical way of implementing a normalized database, right? Where you have the children pointing to the parents, saying that that section, right, is being taught by faculty 2, and this other section is being taught by another faculty, right? This is a classical way you would implement it in relational databases, and you can absolutely implement it here with non-relational databases, right? But now we have the option of implementing an array. Okay, so let's talk about that. When would you use an array, right? And when would you use an embedded? Because now we have these two options, right? Using an array, and we have to choose whether we want to store references or do we want to store the entire object? Do we want to store the entire object? Okay, well, let's consider this option. Let's consider this option. Notice that the faculty, the relationship between faculty and course, notice that it's an aggregation. See that? It's an empty diamond. Okay, remember, what does that mean? It means that there's no life cycle dependency between the faculty and the course, right? If you remove the faculty, not necessarily are you going to remove the course, right? If the faculty leaves, the course can still exist without the faculty. Same thing with the section, right? If the faculty all of a sudden doesn't want to teach that section, that's fine. We'll find another faculty to teach it. So there's no life dependency between the two. Okay, but let's look at this. So in that case, when there is no life dependency, right? When there's no life dependency, then it makes no sense to implement it this way. Okay, because notice that if we implement it this way, notice that the sections and the courses live entirely inside the parent. So that if we remove the parent, the children are also removed. See that? Whereas in this implementation, you only have the references. That means that if the faculty is removed, that's fine, right? Only the references are removed, but the sections or the courses still exist on their own. Make sense? Right? So if it's an aggregation like this, then the implementation typically would be an array of references, right? But if the relationship is composition, right, where, for instance, say, imagine you had a course, and the course, right, you're teaching a course, and the course has different modules, right? If you go to Canvas, right, you have this course, and this course has a whole bunch of modules. You know, the first module for week 1, module for week 2. You have all these modules. What happens if you remove the course? All these modules go away, right? The modules make no sense that the modules would exist even if you remove the course, right? So in that sense, it's a composition relationship, right? All the modules, all the lessons, all the content of this course is gone, right? So it's this type of composition, not aggregation, right? If you remove the course, the modules are gone, and the lessons in there, and the topics, everything's gone, right? So we capture that with a filled-in diamond. So if that's the case, now we can use the embedded option, right? This option down here, right? This option right here, where the objects are fully contained within their parents. Okay. So in this case, you would have something like this. You would have the courses, the collection courses containing, course 1, course 2, 3, 4, 5, any number of courses. And then each course would contain various modules, right? An array of modules where you would have module 1 embedded, and module 2 embedded, right? And then module 1 would have a whole bunch of lessons. You would have lesson 1, lesson 2, lesson 3 in there, and so on and so forth, right? So what happens if you remove course 1? Well, everything goes, right? Including the modules, the lessons, everything goes because it's embedded, it's gone. You would have topic 1, topic 2, and then within lessons. So within lesson 1, you would have multiple topics. Within module 1, you would have multiple lessons, and within the course, you would have multiple modules, right? All embedded inside, hierarchical arrays inside of each other. Okay. So let's take a look at how would you actually implement this, right? So say you implement something like this, right? Modules. Let's see if we can implement this. So DB modules insert. I'm going to insert this particular module, right? So okay, and let's see if we can say db dot modules dot find. Okay, so we have, notice that we have, there we go. See that? We have one module 1, and it contains an array of lessons, right? And notice that each lesson, right, it's an object that right now it has just the name of the lesson, right? If we want to add a new lesson, we can use push. Push, just like $set. Remember, $set allows you to modify an individual field. Push, right? If that field is an array, one way to modify an array would be to append elements to that array. Okay, so you could say, can I make this bigger? There we go. Okay, one way to modify this would be to do a db.modules, right? Dot update, and say I want to modify this guy right here, this module. Okay, and remember, I can do a set. I can set the name. I can definitely do the name. That's easy. We know how to do that. Name, and I can say module 1. Right, we know how to do that. Oops. And there it is. I was able to change it using the set, right? Using set. Or I can do a push. Like, for instance, if I want to change the individual field, I can do a set. But if I want to change a lesson, instead of set, I can do push. See that? Push on what? On the array lesson. Lessons. And in here, I can push a new lesson. Right? I can delete this. Right? And then a new lesson whose name, right? Name could be lesson 2. Okay, now let's print the modules. Okay, there it is. See that? Now lessons has two lessons. See that? Inside of the modules. And so there are objects embedded inside a bigger object. Okay, the lessons are embedded inside of the modules, meaning that if you remove the modules, the lessons are gone too. So I've established a composition relationship between modules and the lessons, right? So there's no such, the equivalent of this in MySQL, you would have to do a cascade delete, right? Where the child has a foreign key that points to the parent, the child lesson record has a foreign key to the parent modules, and it's been configured to do a cascade delete, meaning that if you remove the parent module, it cascades to the delete, right? Deletes also the child lessons. Yeah. Here, there's no such thing, right? Because the lessons are embedded in the modules. If we remove the module, poof, all the lessons are gone, obviously, yes? Okay, so let's continue. Yeah, so we were able to find the module, right? We were able to add a new module. What about if I go in and go a little bit deeper, right? where I want to insert now, right? We're trying to implement this. We have your module contains many lessons, and lessons contain many topics. How about I want to embed now a topic instead of a lesson, right? I was able to embed a lesson instead of a module, but I want to go deeper. I'm going to go deeper and say, well, in the lesson, I want to embed a topic record, right? So let's play around with that. So the way we could do that is, basically, I want to modify this module whose ID is that, right? So so we can say, you know, modify. Let's say db dot modules. I want to update. I want to update the module whose name is module 01. And right, I don't want to modify. I want to modify this module, but I want to modify a specific lesson. Maybe I want to modify this lesson down here. Say, how do I do that? Right. Well, I can specify here. I can specify that I want to modify the lessons dot name. So lessons dot name that is equal to lesson 1. Okay, so remember, this comma is like kind of like an and, right? So basically, this is like a pattern match. It's a pattern match that's saying, well, you know, in the modules collection, pattern match, the one whose name is module 1, boom, meaning I have found my module. It's that one because it's the one who matches module 1, and right within that module, the lessons.name, so lessons.name, okay, matches lesson 1. So it's this one. It's this one right here. That sub-object I want to modify. Okay. All right. So what do I want to do? What do I want to do in there? Well, let's do something simple. Let's change. I'm just going to change the name of the lesson. Let's just change the name of the lesson. So name, I want it to be lesson 01. Okay, this is something trivial. So let's do enter, and let's list all the modules. Indeed, notice that it didn't work. Wait, what? Oh, I'm sorry. Yeah, no. The name? Notice that the name, it changed the name of the module, right? Instead of changing the name of the lesson. No, that's not what I wanted. Okay. So I need to specify what it is that I want to change, and it's always measured from the root of your match. So if you know this is what matched, so it changes name. I need to specify that no, it's down here that I want to modify. Let's change that. Let's so now I change the name of the module. And so this is I'm gonna lesson 1. Let me change it back and be module 01. Okay, change it back. Okay, so let's go back to our query before, right? I don't want to change the name of the module. I want to change the name of the lesson. Okay, so to do that, right? In the update, instead of saying name, I need to say, hey, I want to change the name of the lesson, not the name of the module. And so to do that, I need to say lessons, right? So the array lessons. So go into the array lessons and then change the name of the lesson. But which one? There are a whole bunch of lessons. You need to tell me which one. Well, you can use what it's called a positional operator that says, well, you know, whichever one matched, whichever matched, right? Which one did match here? Was it the first one, the second one? Was it this one? Was it that one? Well, you can say here 0, right? You're saying that I am matching array number the element number 0. So this dot 0 means since lessons is an array, I'm changing the element in the 0th position. right? So for instance, let me show you. If I do that, oops, did I miss something? Set. Oh, I think it needs to be, all right, it needs to be in a string. It needs to be string and string. There we go. Okay, let's try it. Let's find the modules. Okay, there it is. So I noticed that we were able to change the name of that first lesson, right? Or, right, if you don't know the position, say you don't know which one matched, right? We know that the first one matched. Right? We know that the ones that matches the lesson one was the first one. But say you don't know, maybe there's 100 lessons in here, and you don't know which one actually matched, right? So let me show you. Say you're changing lesson 2, well, and you don't know the actual position. Well, you can use a positional operator, which is called $. $sign says, well, I don't know, whichever one actually matched. Okay, use that one. And we're going to change it. We're going to change it to the name saying, oops. I broke it. Sorry. Where'd it go? Okay, there we go. Yeah, so let me do lesson 2. And so we're going to put $sign here, and I'm going to change it to 02. Okay, if we do a find, notice that indeed we was able to change the lesson to the one that matched, right? So it remembers, right, which one actually matched the $sign, right? And then it replaces it with the actual index of the element that matched in the array. Okay. All right. Okay. Yeah. So what actually we wanted to do is now store a sub object under there, right? Like for instance, we want to set another array under lessons, right, that contains topics. Okay, so let's do that. So for instance, instead of saying set, right, name is a field that already exists, but I can add other fields. Like for instance, I can do topics as a brand new array, right? And in there, let me make this, I can't see. Oops, can't see that. What? Oh, the chat doesn't let me see. Yeah, so here we're going to add a brand new array. Topics is a brand new array, right? And the first array element is going to be a topic whose name, right, is say topic 01. Oops, that didn't work. Module 1 lesson topics. Did I change it? Lesson 2. Oh, I renamed the lesson. So this needs to be lesson 02, right? Lesson 02. Okay, that should work. There it is. Notice now that the module 01 contains an array of lessons. The array of lessons contains many lessons right here, and then the last lesson contains a new array of topics, right? That you have a whole bunch of topics under there. See that? Right, and this is what we mean by, objects could be arbitrarily complex, containing each other, right, and then embedded with having objects that are embedded inside of each other, and which is great for implementing large complex objects. And this is actually the preferred way of implementing these things that provide the fastest access possible from MongoDB. And this is what I meant by whether you can get away with it, right? If this topic only makes sense that exists inside of this lesson, and this lesson only makes sense that exists inside of this module, and that this module only makes sense that belongs to a particular course, then by all means implement it this way, right? If you instead want to be able to use modules across multiple courses, right? I don't know that you would do that. Maybe you want to have the same module across multiple sections. Then yeah, you should be able to do that as well, right? You would have its own container, its own collection, right? To be that would allow you to refer to that module in different places, right? With references, as opposed to using this embedded implementation. Okay. All right, folks. I need to run. I'm gonna leave it here. And the video should be available soon on YouTube. Okay.
Thanks, Professor.
All right. Thank you.
Thank you very much.
Bye.